Let's solve a kinematics problem involving a ball being dropped and a stone being thrown upward. A ball is dropped from the top of a 50-meter-high cliff. At the same time, a carefully aimed stone is thrown straight up from the bottom of the cliff with a speed of 24 meters per second. The stone and ball collide partway up. How far above the base of the cliff does this happen? Let's start by drawing a diagram of the situation. Here's our cliff, 50 meters high. The ball starts at the top and is dropped with zero initial velocity. And the stone starts at the bottom and is thrown upward with a velocity of 24 meters per second. Let's set up our equations. We'll use the kinematic equation that relates position to time. Y equals y initial plus v initial times t plus 1/2 a t squared. For the ball, starting at 50 meters with zero initial velocity and acceleration of negative 9.8 meters per second squared downward, we get y equals 50 minus 4.9 t squared. For the stone, starting at 0 meters with 24 meters per second initial velocity upward, and the same acceleration downward, we get y equals 24t minus 4.9 t squared. When the ball and stone collide, they must be at the same height, so we can set these equations equal to each other. 50 minus 4.9 t squared equals 24t minus 4.9 t squared. The 4.9 t squared terms cancel out on both sides. Solving for t, we get t equals 50 divided by 24, which is approximately 2.083 seconds. Now that we know when they collide, we can plug this time back into either equation to find the height. Let's use the stone's equation. Y equals 24 times 2.083 minus 4.9 times 2.083 squared. Calculating this out, we find that they collide at a height of 25 meters above the base of the cliff. Let's visualize this collision. This makes sense because the ball falls from 50 meters and the stone rises from 0 meters, so they would meet somewhere in the middle. The exact height depends on their relative speeds, which we calculated using kinematics.